Okay, so F is a map from R3 to R, and consider the surface S defined by f of x equals 7. Okay, so said another way, the surface S is the preimage of 7 under the map F. Okay, and we actually know this map. It's one of our key examples. So the preimage of 7 will look something like this. And so somewhere on there is the point P. P equals the point 2, 2, 1. And when we plug it in, we get 7. So f of P equals 2 squared plus 2 squared minus 1 squared, which is 7. Okay, and so there's a normal space and a tangent space. So I just drew the tangent space. And then the normal space comes out. In this case, the normal space is a line. Yeah, okay. So that's what we're looking for. Now, the gradient of f is a vector field, which in this case sends the points x1, x2, x3 to the vector 2x1, 2x2, minus 2x3. Okay, so the gradient of f evaluated at the point P, well, that is a vector. Namely, if we plug in P to the gradient, we get out this vector. What is it? Well, maybe I'll write it vertically. It'll be 2 times 2, 2 times 2, and minus 2 times 1. So check that you understand what I just did. Plug this in. Okay, so this is a vector. It's 4, 4, minus 2. Okay, so the normal space equals the image of the map. Well, what map? How about C goes to C times 4, 4, negative 2. So C is a real number, and this is R3. Okay. And then the tangent space to S is equal to actually the preimage of a map, or another way to say it is all solutions to the equation, in fact, the linear equation, 4x1 plus 4x2 minus 2x3 equals 0. Okay, so here even though I drew the shifted normal and tangent spaces. And so if we wanted to get the shifted normal and tangent spaces, these ones right here would pass through the origin. So they're what were later called subspaces. But if we wanted to shift them, then we could do that too. We could just add a f of p here. We'd have to add a p plus this to shift. And then over here, we'd have to change this number. Change to, change to something. What would it be? Change to 4 times 2 plus 4 times 2 minus 2 times 1. I'm plugging in the point P to this equation, and I see that I would get 16 minus 2, 16 minus 2, which is 14. So I'd change that to a 14 to get the shifted tangent space. And I'd change this map to be another map that said, start at 2, 2, 1, and then add some amount of this vector. And so this is the shifted tangent space to S, and this is the shifted tangent or normal space.